Now recall that when we had 2 points at some distance from the origin along the x-axis, and we put the condition that the sum of the distances d1 and d2 is constant on the points that we're going to use, we saw that those points form an ellipse of the form x squared over a squared plus y squared over b squared equals 1. Turns out that there's a relation between a and b in this distance c that isn't too difficult to determine. A squared equals b squared plus c squared. That means that if we know a and b, we can easily find c. Alternatively, if we know c and either a or b, we could find the other. Or if we know c and the sum of the distances, it turns out that we could also find a and b fairly easily. Now, you should actually have the experience of sketching an ellipse by on your own. I'm going to sketch an ellipse here on this paper. I'm going to attempt to sketch an ellipse. It's not going to be a real good ellipse because I'm using kind of heavy string, but I've got a thumbtack and a string. I'm going to put the thumbtack through the string, hopefully not through my finger, and I'm going to locate that at some point here. And then I'm going to put another thumbtack through the string, and I'm going to leave some slack in the string. Now I'm kind of blocking myself here, but I can't help that. Maybe put the thumbtack here. And now I'm going to draw an ellipse. Maybe. This string is pretty heavy, so this isn't going to be a real good ellipse, but this is what you do, and you can draw your own ellipse. Okay, I can come out here, and I'm just keeping the string kind of tight as I move around. Okay? Now, by keeping the string tight, of course, the sum of this distance and this distance from here to here, okay, the sum of these two distances has to be the length of string that lies between these 2 points. Now, again, this string is kind of curvy. It's kind of fat string, what I had handy here, so that I'm not going to get a perfect result. You see, I've drawn half of an ellipse. Now, if I come around and attempt to draw the other half, a little more quickly maybe. Yep, going to move the paper. But you see that we're forming a pretty good ellipse here, actually. Now, there's my ellipse. The 2 thumbtacks are the foci of the ellipse. This is one focus, this is the other. If I draw my x-axis here and my y-axis and my x-axis here, then this distance is c, and this point will be C0. Let's zoom in on that a little bit so you can maybe read it. This point will be negative C0. This point will be 0b. This point down here, of course, will be 0 negative b. And this ellipse will be contained inside the box that we've indicated. And these distances, let's say I've drawn the point A0 here. Here's A0. And here's negative A0. We could measure the distance A, we can measure the distance C, and we can measure the distance B. If I had a ruler handy here, or if I'd have thought ahead and put a ruler close by, I might have been able to do that for you. Actually, I see something I can use. Okay, now I'm just going to make a measurement here. It looks to me like A is 8.4 centimeters. C looks to be about 7.3 centimeters. And B appears to be about 6.5 centimeters. We should have a squared equals b squared plus c squared. You can check out and see whether we do. And you can, of course, draw your own ellipse and make your own measurements and validate this for yourself. Now, when we did something similar to this in class, we actually drew an ellipse on the floor. And we measured A, B, and C. Now, we measured the ellipse on the floor by holding the string down. Two people held it down with their thumbs, and another person drew the ellipse. And the ellipse isn't far from the camera here. I could show you, but somebody's apparently practicing witchcraft or something. They have certain symbols on it. Nothing I would particularly think people would find offensive, but we're not going to look at that ellipse anyhow. We don't have time. The ellipse on the floor was determined to have these dimensions. Now, we did these in feet by estimating, because the tiles on the floor are 1 foot squares. So that's why we have feet here, not meters or some more sensible unit of measurement. Checking out to see whether a squared equals b squared plus c squared. If we plugged in these numbers, the equation became 6.50. Should be approximately 6.96. These are close. They're not perfect. But remember, that string didn't behave perfectly, and you probably won't get a perfect result for the ellipse we drew on the paper either. If you use a fine thread and draw the thing very carefully, you do come up with very good results.